Okay, so now that we know how to name triangles by both the side and the angles, we're going to do some practice looking at measurements and determining the classification of both. And we'll do pictures later. So the first one says, and for some reason the degree symbol is not showing up, but the first one says the angle measurements are 30 degrees, 40 degrees, and 110 degrees. So automatically, if we're looking at and thinking about an angle, I see that there's an angle that is 110 degrees. And I know I just learned that when I have 110 degrees, that's talking about an angle that's greater than 90, which we call obtuse. So I know that when I pick my answer, it's going to have obtuse as part of the name. I also see that the angle measurements are 3 different measurements. Well, I learned when I was talking about the sides that whenever I have 3 different measurements on the outside, it also means that I'm going to have 3 different angle measurements on the inside. So this triangle here is going to be classified as an obtuse scalene. An obtuse scalene. So it's going to be this one right here. So cross it off. Well, actually, I'll leave it open so just in case you want to go back and write this stuff down. So the next one we're going to look at is a triangle that has a 90-degree angle and then 45 degrees and 45 degrees for the last. So I see here that I have this 90-degree angle, and automatically I should be thinking in my head, that's a right triangle, because a right triangle has exactly one 90-degree angle. So the other 2 angle measurements are the same, which means that I'm looking at a triangle, since it has 2 equal angles, that has 2 equal sides. And I learned that triangles that have 2 equal sides are called isosceles. So this triangle that has a 90 and then 45 degrees is going to be a right isosceles triangle. A right isosceles triangle. The next one says that we have sides of 2 inches, 2 inches, and 2 inches. Well, since we're talking about the outside of the triangle and the measurements of the sides, and they are all the same measurement, I know that this is talking about an equilateral triangle because that means that all sides are equal. It's the easy one. The next one says 57, 88, and 35 degrees. None of these degree measurements are matching, and none of the degree measurements are greater than 90. So if I'm looking at the angles, I know that since none of them are greater than 90 or even equal to 90, that I'm going to be looking at an acute triangle. An acute triangle because the acute triangle is where we have no angles that are greater than 90. So I know the angle type is acute, and since none of the angle measurements are the same, that the outsides are going to have all different side lengths as well. So this is going to be an acute scalene. All right, the next one. It says angles are 110 degrees, 30 degrees, and then 40 degrees. Automatically here, that is way bigger than acute. It's bigger than 90 degrees, which means that I'm going to be looking at an obtuse triangle. It's going to have an angle that is wider and greater than 90 degrees. And then the other 2 angle measurements are all different, okay? So I'm looking at an obtuse triangle that has all different angle measurements, which means that it's going to have all different side measurements. So the triangle that has all different side measurements we call scalene. So this is an obtuse scalene triangle. The next one has sides that are 10 centimeters, 10 centimeters, and 18 centimeters. So I know that when I have 2 side lengths that are the same, that's talking about an isosceles triangle. Okay? So this one's a little bit tricky, but you can think of it like this. Since the side lengths are going to be 10 centimeters, and the last one, you can draw a picture, it might help. The last one is going to be 18. Well, 18 is bigger than 10, so it's going to make this line here wider. So this is 10, this is 10, this is 18. And so what happens is it opens up this angle up here and it becomes very wide, greater than 90. So this is going to end up being an isosceles obtuse triangle. An isosceles obtuse, or an obtuse isosceles. Sometimes you have to draw pictures to really help you see what's going on, and that's totally fine. I think that that's a great strategy. The next one is where we have angle measurements that are 60 degrees, 60 degrees, and 60 degrees. Well, if I have all equal angle measurements, that means most of the time that it's going to be, well, it is an equilateral triangle. I'm not sure why it doesn't have an equilateral with another name, but since the angles are all less than 90, it's going to be an equilateral and it's going to be acute, okay? So it's an acute equilateral. And I'm not sure where this answer choice is here. So I'm just going to put next down here, acute equilateral, and go with it. We'll say that's H. Okay. And this one, it says sides are 3 centimeters, 4 centimeters, and 5 centimeters. So all of these all of these sides are different side measurements, right? Well, with different side measurements, that means that we're looking at a scalene triangle. Now, this is going to be a little bit more than what you've learned like so far in math, but you'll learn next year, or maybe this year, later at the end of the year, that we have this thing called the magic triangle. And the magic triangle is talking about a right triangle that has sides that are 3, 4, and then 5. So this is talking about, and I don't expect you to know this, but it's just a little extra information. This is talking about a scalene triangle that is also a right triangle. So that would be letter B.